All right, so it says, clear the graph, place several points on the graph that lie roughly in a straight line, and then hit show line. The line that appears is called the regression line. Okay, so let's put some points that are pretty close to being on a line. I'm going to have these points have more or less a positive slope. Notice that I have more than 1 point, and for more than 1 point, it's likely to be impossible to connect all these dots with the same line. So when I click Show Line, the line is going to get as close as it can to all the dots, but it's not going to be perfect. Okay, so let's draw this right here. So I'm going to snip it into the presentation here. All right. So that's what you need to draw. And I'll wait for a couple of seconds for you guys to draw that. Okay, so I'm going to write over here to the side some of the things that I notice about this line. The first is that the slope is positive. Okay, the slope is positive, and in fact, according to the equation, that's not the procedure. Okay, so the slope is positive, and in fact, according to the equation, it's positive 0.6. So I'm looking at the number in front of the x. So it makes sense because the slope is positive, it's 0.6. And then the intercept is positive, and that makes sense because it's up here, so it's 7.9, which makes sense. So in fact, b equals 7.9. According to this equation right here, I'm still looking at this one. And then it tells me that r is 0.99. Okay, so that means I can answer this question for the r value, 0.99. And the important thing is that this is very close to 1, very close to the number 1. Next one says, place 1 additional point on the graph that lies far away from the line. Okay, so I'm going to look at this r value, 0.99, and what is the effect if I put a dot, what's called an outlier, something that doesn't fit. So let's put a dot down there. Okay, so if I put a dot down there, what effect did it have on the r value? Well, the r value went down to 0.8. So I pushed 1 additional point and it changed to 0.83. In other words, the r value got, let's see, moved away from 1. Okay, so what I'm trying to prove to you here is that the r value is a measurement of how close the dots are. So if the dots are very close together, it means that r is very close to 1. And then it says move up several of the points. Okay, so that I can actually move some of these points. So what if I move this point so that it's not on top of the line? So I can move that, well, I can just plot. So what if I made a whole bunch of dots here that weren't on top of the line? So the r value gets worse and worse, that is, it gets closer and closer to 0. Okay, so the r value got closer to 0. The r value got closer to 0. All right, so what we've learned is that there's actually a number that tells you how close together dots are. It's called the correlation coefficient, or otherwise known as the r value. When you're drawing a line of best fits, you get as close to as many of the dots as you can, and the measurement of how spread out the dots are away from that line is called the r value. If it's very close to 1, it means that your data is really good, and then if it's close to 0, it means like this one's close to 0, and if it's close to 0, it means your data is all over the place. So this would be called a weak correlation. The closer the r value is to 0, this is weak. The closer the r value is to 1, like this one, this is strong. Okay, so this is a strong correlation, and it's also a positive r value. So the r value is positive, so that's a strong positive correlation. Okay, let me clear this off. I'm going to plot a strong weak correlation, or a strong negative rather. Okay, so it's strong because it's exactly 1, and it's negative because it's going down. And then I could move these dots all over the place. This is now a weak correlation, but it's still negative because it's going down. All right, so there's 2 things to look for. Is it going up or going down? And then how tight together are the lines? And we have at last gotten to really the only thing that you need to remember for the final, which is by looking at the line or by looking at the data, you can tell if it's positively or negatively correlated, and is it strongly or weakly correlated. All right. This data is going up, okay, so that means it's positively correlated, because the line is going up, and R is, okay, so I can tell by looking at the data, because the line is going up, that is the dots are generally trending up. And then if I look at the R value, it says R equals 0.87, so R is positive. So R will tell you if it's positive or negative correlation. That's this measurement right here. And then it says, are these data strongly correlated or weakly correlated? I would call these weakly correlated. Because the dots are spread out and R is not close to, what number does it need to be? It needs to be close to 1. Okay, so the smaller the R value is, the worse the correlation. And it can only go up to 1. 1 means perfect correlation. All right, so this last one I'd like you to do on your own, and I'd just like to point out that I've got some dots here, and then this red line is what I'm talking about. It says, are these data positively correlated, negatively correlated, or show no correlation? How can you tell? Are they strong or weakly correlated, and how can you tell? And then the other thing I'd like to point out, there's 10 dots. The R value is negative 0.98. All right, please do these two on your own.